So now we have finished our model. One of the next thing we can try to do is to validate our model. As we know, to validate the model, we need to find a real complex pattern from the real world. And if our model can simulate similar patterns, which is matchable to the real complex pattern from the natural world, then we say that validates our model. And we do know a complex pattern that is similar to the one in this video. That is, we have three piles of food. Although these two piles are in the same distance, the ants colony will trying to use its majority to finish one pile of food first, and then second, and then third. It will not trying to take food from three sources at the same time. This is the real observation from natural world. So our model is supposed to simulate that. If this is what our model are capable of doing, or can be set to do that most of the time, then we say it validates our model. However, although we can make the model work like that, but we're not quite sure whether that particular set of parameters is just happen to work by chance or actually it work most of the time. We're not sure because we can only try it within. For us to manually try it is very inefficient to try all sorts of parameters because that's the infinite amount of numbers to try. Therefore, we need a more automatic and faster way to experiment it. To help us know this can be achieved most of the time as long as we set the parameters right. And also, patterns like this, getting two piles of food at the same time, can also be the results of a different sets of or different range of parameter setting. So that's this pattern. So in order to use the parameter search to distinguish these three types of patterns, we have to use a tool called behaviorSearch to help us design the experiments. We know that to achieve what we have seen, we need a lot of parameters. In the model, we have 4 parameters, and in order to see which parameter for which range of value are responsible for which pattern, we obviously need to provide more than one value, probably a range of values, and ask them to make combinations. And for each combination, we will try to do 100 experiments and take the value, and then we can compare the values. And suppose those 3 different patterns can be measured. These 3 different patterns can be measured on the same metric. They just take a different range of values. For example, I try to define a metric, say metric m. So for these 3 type of values, maybe for this type of pattern, the value m is very low. And maybe for this type of pattern, the value m is in medium values, and the last type is in high values. If my metric is capable of differentiate these 3 patterns into 3 ranges of values, then that can be considered as a success of design metrics. So in that way, we run these experiments for, say, 28,800 times. Then we get all those data. Then we can plot those data and to see whether it is true that for all those 3 types of values or the 3 types of patterns, the m value is in different range. And it is so, then we can be confident that certain range of parameters are responsible for certain type of the patterns. But the difficult thing here is how to design such a metric. So far, the metric which I have designed is a ratio thing. That is, we use, because as the model iterates, every pile's food will decrease. Of course, all the piles of food will decrease as well. So I create a ratio. Ask each pile of foods, the sum of its food left divided by the food in the whole world. So we have three ratios. So when the model runs, the ratios will differ. So we can have a look. For this one, the pattern is quite obvious. The first pile of food which disappear will drop first. This is first pile. And then second pile, drop second. The last pile will shoot up to 1. So visually it is quite distinguishable. And for the second pattern, it's different way of moving. The first two moving downwards, but not very close to each other. And the third pattern. Well, this one, although the pattern is different, but this metric shape is quite similar to the second one. Therefore, the M metric only works for pattern 1, not very differentiable for pattern 2 and pattern 3. Therefore, my metric is not quite suitable. We need a more sophisticated metric to achieve the differentiation of these three patterns.